Hello everyone. JaCoV is here. Glad to see all of you on our new webinar. So sorry for a small delay because we have some troubles with connection. So yeah, now we are here and JaCoV is here and new webinar is here. Hello everyone. So today we'll have really nice webinar about CICD platform, which is delivered at EPAM, and I'm really hope that it will be useful as all our webinars. I want to remind you that we are on our YouTube channel, or YouTube channel of JaCoV, and here we have more webinars, and we will have more webinars, and more webinars are coming here to our channel. So if you are interested in this and want to receive updates on every new thing which will come here, so please go down under this video, click subscribe button, and click like button and click bell button, so algorithms of YouTube likes that, and we will rise high, and more guys will know about our webinars and join us, and our community will grow. Also I want to say that in the description of our channel there are a couple links. So first of all, it's our Telegram chat, so you may join it, and there also you may receive notifications about our webinars and our events, and also have some discussions with other guys about what's happening here, and maybe discuss some topics. Also, we have some videos from JavaZ Day released each week, the topics which were on JavaZ Day. So we also post updates about these topics there in this channel. Also, there is link to our community page on Community Z. And also, if you want to be a speaker, if you want to join us as a speaker, feel free to reach me. There is my link to my Telegram chat with me, so just click there, type to me, and if you want to be a speaker, if you have topic, if you even don't have topic, we'll try to help you and we'll try to prepare something. So if you have willingness to become a speaker on our JaCoV initiative, so just ping me and we will try to think something about that. Okay, so let me welcome here our today's speaker, who will present his topic. Today we'll have a talk from Sergey Kulanov. Sergey, hello, how are you?
Hello, fine, thank you.
Great. You're live, just want to mention that. So, just a couple of words before we begin and before we proceed. Could you tell us what will be your topic about?
Yeah, so actually today we're going to talk about the CI/CD processes, how we are establishing it on our projects, and how we use EPAM Delivery Platform to ensure that those guide rails of code shipping to production is well defined. So here's what in general we are going to discuss today.
Okay, good. I really hope that it will be useful for guys who will listen to us. So I just want to mention, guys, if you don't have CI/CD on your project, you should have it. And I hope that today's talk will help you to do so. Okay, so let's not waste the time. I pass the voice to you, Sergey. Just want to mention one thing. We have YouTube chat here. So guys, if you have any questions regarding the topic, please pass your questions there. I will look on all of them, and we will ask them to Sergey when we will have time for questions. We will definitely have time for question and answers in the end of the topic, maybe in the middle. So just put your questions there, and we will see them, and we will announce them. Okay, Sergey, good luck with your talk. I will just show you screen. Just give me a second. Yeah, Here it is, and good luck.
Yeah, hello everyone again. So today we're going to talk about CI/CD as a code and how we are achieving this using EPAM Delivery Platform. So my name is Sergey Kulanov. I'm a system architect at EPAM with approximately 4 years. And in general, I'm 15 years in IT, and the last, let's say, 7 years, I'm playing mostly DevOps-related roles and all the stuff related to CI/CD establishment, infrastructure provisioning, and all other stuff. So the area of my interest is here is CI/CD, containerization, cloud, and here are some links to one of my resources. So today agenda, what we're going to discuss, I will do a brief introduction to the EPAM Delivery Platform. I will also describe EDP, where it stands comparing with other tools, because it's crucially important to understand should you go with this product or no. I also describe a high-level architecture and operator pattern we're using for implementing EDP platform, which enables us to define CI/CD in code. In CI/CD for pipelines, not only for the pipelines, but for the toolset which provides CI/CD capability. And I will do a brief live demo with all those thoughts I've just mentioned before. So I also shared a little bit on lessons learned, what should be taken into account if someone decides to go the same way, and the further steps we are going to do with EDP team. So the problem statement in general. So I can say definitely please raise your hand and say how long does it take to, I don't know, to onboard a new application into your software delivery process in existing development environment. So I don't say that from scratch. I'm even mentioning that you have already some pipelines, you have already some applications, you have Java applications, Python, whatever. You have infrastructure pipelines to provision some part of the infrastructure. Again, how much does it take? How long does it take to establish these CI/CD pipelines from the very beginning? So sometimes it can take, I don't know, 1 minute, 2 minutes, depending on what technology stack you are using, what approaches are you using. This can be just adding simple YAML file to some source code and, I don't know, GitLab CI or other tool, just create those pipelines from scratch. This can be some self-service using Jira or, I don't know, ServiceNow approach, and you'll just go there, just click select what application you want to provision, push the button create, and here you are. So CI/CD as a code is more technical term in our case, and we are going to discuss today mostly not just CI/CD as a code, but how we can reuse different library approaches which can define these guide rails or CI/CD processes, and how we can just replicate them to introduce or onboard new application, new library, new environment to your software delivery process. So the benefits are obvious. So you are mostly focusing on value delivery instead of just reconfiguring all pipelines from scratch. You just decrease time to market, and yeah, you are, as I said, you are reusable all your components, and it increases your team's agility and autonomy. So instead of having like a bunch of DevOpses inside your team, you can just use a self-service. I will later show the capability of EDP here, and just, let's say, just onboard and run CI for your application in a really simple manner. So what is EDP? I've just copy-paste some basic description from our publicly available source. It's an open source and cloud agnostic SaaS and PaaS solution. Is under Apache license 2, so you can go there, just clone this repository and do the installation, just read all the documents related to this platform, and it provides out of the box a number of pre-existing pre-configured CI/CD tools and pipelines, which enables you to work with your application. It should be also mentioned that this application, the target application and architecture in our case, is microservices, and we also started in implementing, let's say, pipelines for infrastructure as code. I will later provide you more information on these technology stacks. So as I said, EDP consolidates open source tools and run them onto the Kubernetes or OpenShift cluster. So comparing with other tools, this is a really huge table. I will just briefly describe some of the critical criteria you should take into account while choosing which one tool to be selected. So as I said, EDP is free. Meanwhile, other tools which you see on the screens, they are also free, but for with some specific limitations. For example, if you have an open source project and you don't need to hide your repository under your firewall of your company, or it's not like an enterprise and public solution, then your choice can be some public providers which provides you CI/CD out of the box. So it can be GitHub Actions, GitLab CI, whatever. Azure DevOps as well, and they even have, like, you can run your own self-hosted environment here as well. There are limitations, and you need to read about them. Regarding costs, again, EDP, you are paying only for the infrastructure you are consuming by your pipelines. Meanwhile, for the other providers, this can be additional cost for the licensing, for the number of users on your project, for the number of parallel pipelines running at the same time, whatever. So this can be any type of monetization, actually. So regarding code storage, so EDP now supports only 3 tools which stores code for your repository, code for your project. This is Gerrit out of the box, which we configured, and we can also grab the code from GitHub or GitLab. Meanwhile, you can see that other tools can support broader number of these integration points. So regarding the declarative approach of pipeline definition, here EDP supports both declarative and descriptive. So you can use both with EDP. For the rest of the applications, the most cases, they're using declarative native approach. You just need to create some YAML file with some predefined steps and just populate with your own values, and that's it. So workflow library, one of the main, let's say, killer feature for the most of the products is that capability of your product to provide an out-of-the-box solutions for some of the problems or some of the approaches or some of the technology stacks you use on your project. For example, if it is Java, then you can go to this library, you can pick up some pipeline which is already created by some team, by someone shared with you, and you just copy and paste in the code, or even import this library and run this workload on your own. So this is one of the criteria you should check before starting any CI/CD projects. So regarding maintenance cost, here we have a high and medium maintenance because we are running our own toolset. So there must be some guys who is just watching these tools and ensure that they are up and running. For the rest of the products, mostly they are running in the cloud, and this can be another potential blocker if, for example, you have some financial sector or some customer which said, I don't know, I want to run everything in a private cloud. If you have some CI/CD solution, please deploy it on Perm. I also want to review, I don't know, some security specific issues or whatever for this specific application. So artifacts here as well, you can select and check which one is the best for you, because some of the tools which you see on the screen, they are not providing any artifact storage for you, and you have to configure beforehand some third-party services like Sonar Cloud, or it can be Artifactory from JFrog or whatever. So language support, actually this is a technology stack, and most of them are support almost well-known existing technology stacks for now. It can be Java, Python, Ruby, C#, whatever. So, and going to this link, you can check later, like it's really huge and rich. So monorepo support, this is, I believe, a separate topic of discussion, but yeah, some of the platforms or some of the providers of the CI/CD also checking the possibility to provide monorepo support for their clients as well. And then security check, static code analysis. Mostly all of the providers described on this slide, they require some third-party integration beforehand, like as I said before, Sonar Cloud configuration if you have some security checks or whatever. So you also should be configured beforehand, integrate with some, I don't know, with some API or whatever. And now what is EDP provides out of the box. On this screen you can see with the green boxes is that what is implemented. Something that is still in alpha. I mean, we're using it, but it's not in product yet. Planned is what we want to do in the next our releases, and external systems that what we are integrated and used for up and running EDP. So if you look on this slide, at the very bottom of this slide, you can see that we provide provisioning of all the stuff related to Kubernetes cluster out of the box. So if you don't have cluster, we can provide you a script which will spin up the cluster. Also, we do some configuration on the Kubernetes cluster level and provide you with multi-tenancy, logging, monitoring, backup, and alerting. So agree that this is like out of CI/CD stack, but again, we provide this. We also start like investigating and using some secret managements as well. And I believe so this is another topic of the discussions, because secret managements is also raised when you starting developing some applications. And EDP itself, so you can see the toolset which are currently provided out of the box. They are pre-configured, integrated with each other, and work at a single holistic system. So we are currently working on the releases and integrating Argo CD as a deployment tool for your microservices. So regarding the other providers, GCP and Azure, we have some scripts, but let's say they are not production ready. We do some POC, we run even some projects on these infrastructure cloud providers, but again, they are not in the box. So now not go with EDP. As I said before, if you're not open source, so why you should go with EDP? You're not open source and your projects must not be publicly available. You are aligned with the technology stack, which has EDP. I will later show this stack. Your budget is approximately $80 not sorry, it's not 100, but $80 a month for infrastructure. So you're paying only for the infrastructure, which is consumed by the EDP itself. Your target architecture is microservices. This is also highly important, because sometimes if customer want to manage, I don't know, serverless framework or anything else, then this is not out of the box with EDP. You can write your custom Jenkins pipeline, run it, and it will work. But again, if we are talking about the self-service which EDP provides, then the target architecture is microservice. So what else? Why you need to select EDP? If you need, for example, to provide some POC in a couple of weeks, so you want to do some sketches, some simple stuff, and just to demonstrate customer how the stuff works, I don't know, in containerized environment. So if you need highlight pipeline customization, if you have some request to trigger some pipelines based on the some input data, so this is the best way to go with. So, and some of the others are like, if you plan to use Terraform for infrastructure as code, because if you want to go with Pulumi or, I don't know, CDK stack, then EDP is also not well in this, so we're not providing it out of the box. So if you also don't want to care about establishing Kubernetes cluster with best practices, I mean, like if you want to have all this out of the box and not only EDP, and you want this cluster be up and running, you want to install monitoring stack, logging stack, you want to provide namespace as a service, then EDP here is well to go. So, and the last one, if you don't have a strict requirements for the customer, because he can say, okay, I need like GitLab, I've bought it, and so please go with GitLab. And another one, probably you are doing some projects before and you have some pipelines from your previous project, but sometimes it's not possible to share it because it was the customer, it was developed under NDA or some license restrictions. So this is another way to go with EDP. So EDP toolset, in short, as I said, EDP as a code review and code storage. We are working with Gerrit. We're installing it explicitly on a platform if someone wants to work with Gerrit. And then we can also work with the code which is stored on GitLab or GitHub site. So workload execution, we support Jenkins. So, and actually this is our main tool for workload running. Later I will show in the future on our on our plans to introduce Tecton for this as well. And we also support some very, very basic CI from the GitLab side. So for the static code analysis, we're using SonarQube. For artifact storage, we're using Nexus. ECR for storing images, but we also can store images in Nexus, and Docker Hub as well. So for Kubernetes and deployment approach, we're using raw YAML if we're talking about the OpenShift, but again, Helm chart works here as well. And if you have your project and you are willing to work with Customize or other tools, then out-of-the-box EDP doesn't work. So it will require requests to our team to extend it for this functionality and to end this deployment approach. So we're using Allure as a testing report tool, and as I said, infrastructure as the code is currently addressed by Terraform tool. So technology stack. If you have some of these tools you see on this right side of this slide, and they're aligned with the project, with the technology stack for your project, then you are free to go. If this is something, for example, Ruby, in our case, Ruby, and you need to start it like from day one, then you don't have this tool. We don't have an EDP, and it will require additional effort from our team just to onboard this tool. I will not say that it will take like months or years, so probably 2 weeks will be enough to introduce a new tool to our stack. So moving forward, now let's talk a little bit about architecture, because actually this architecture provides us capability to define everything as a code. CICD as a code, pipelines as a code, whatever. As I said before, on the very low level, we require infrastructure as a service. This is where we need containerization orchestration system, and we're using heavily Kubernetes. And on the next level, we have our EDP tools deployed, and all other tools which are required to be properly functional and work with EDP environment. And then specifically those developers or namespaces, environments which are used to run microservices, to develop microservices, or whatever. So we also have an integration with single sign-on. I will show you during the demo. And on the very top level, we have a pipelines to managing all those stuff. Again, we can run on any Kubernetes environment. This even can be an OpenShift, and it can be deployed in AWS, Google, Azure, whatever. So we just need a Kubernetes cluster in the final. So deployment approach. It's also important to mention the deployment approach, because starting with the deployment, I will just describe on how these capabilities of definition everything in the code provided by this deployment approach. You can see that on the very top we have EDP install Helm chart, which actually is an umbrella for other components of EDP. And you see here on the left side is the list of operators which are actually up and running in the cluster, and they ensure that our system function in the exact state which we defined in our custom resources. So these charts install custom resource definitions. I will later show you what does it mean, and then defines a custom resource. Operator then check the status of this resource and align our software, our Jenkins in our case on this example, with the state which we want to achieve in this custom resource. So this is what EDP does. It deploys some operators, it deploys some custom resource definition, custom resources, and definitely some deployments, config maps, and other Kubernetes objects to ensure that the platform functional properly. Now the baseline of capability of CI/CD as the code. So we're using operator pattern. I will describe how it works later on the next slide. But the general, the foundation of all of this stuff is that we're using custom resource definition, which allows us to extend Kubernetes API with our own custom objects. And then we can instantiate our custom resources with predefined state we want to be achieved, and then operator will just configure our application to the state what we want what we defined in our custom resource. So this is how it looks like from the technical perspective. We just define this custom resource definition. For example, on this slide, you can see code-based image streams. By the way, today's during the demo, I will also describe and show you what information do they have and how they're used during the deployment. So now let's go to the next slide. I've mentioned already about the operator pattern. Again, we're extending Kubernetes API with our own custom resources. In our case, for example, this is Jenkins. Then there is a custom resource in which we defined to which state we want our application, in our case Jenkins, to be aligned. And we define the desired state. Then there exists a Jenkins controller which actually implements this custom logic and ensures that, for example, if I add a new volume to Jenkins, then this custom controller should implement this logic. It should be triggered, see that, okay, user want to mount a new volume, then I need to provide this volume. And the custom logic which we implement this controller ensures that this volume will be created, properly mounted, or whatever. So everything you need to do as an operator with your Jenkins instance. Do you need, for example, create a secret in your Jenkins? You can do this UI, but it's better to go with this approach because we have an entity which is responsible of provisioning, for example, SSH keys. For example, you need to integrate your Jenkins with some third-party code, which is on some third-party Git server. So you just define the custom resource with all the required information saying that, okay, Jenkins, please do this. So Jenkins controller runs all the stuff, checks and creates properly all the required configurations on the Jenkins side, and then report the status, was it successfully or no. If it was not successful, then reconciliation loop runs and ensures each time that you are in a proper and desired state. So after having all of this information, now let's go to the defining CI/CD in the code. So EDP CI pipeline, probably you've seen this picture many times, not only related to EDP, but if you're using GitLab, using GitHub CI or whatever, or GitHub Actions. Yeah, so nothing new in EDP. CI pipeline looks like this. We have two, let's say in our vocabulary, we have two definitions. The first one is the code review pipeline, which is ensures that your code is not merged until the code review pipeline will not return everything is okay. And if everything is okay, then user can approve and merge this request, and then a build pipeline triggers, which can do some different steps, but they are mostly the same as on the continuous integration pipeline. And then as the result, user will have artifact in his artifactory. For example, this can be Maven artifact, this can be Docker images, or whatever. CD pipelines. So probably I will mostly talk later about these CD pipelines because this structure you can see on this slide, we are going to describe in a YAML file, and then we will ensure that our operators, which we have, align our Jenkins, Sonar, Gerrit, and other tools to work according to these pipelines. So here are some examples. You have, for example, some microservice client which has some release, for example, one. You have a new feature, order 5, I don't know, and developer want to work on this feature. So he just picks up this timed release because it's stable, it already released, and deploys together with this changed code from his order feature. He does it actually manually from this slide. I will later show you how it looks like. And if everything is okay, then he can, if everything is okay, then autotest runs against those two entities. And if there are no issues with autotests, then this artifact can be promoted to the higher environment. In our case, it is QA. Then QA people can manually deploy this artifact on this environment, and if everything is okay from their side, I don't know, from manual QA perspective, they can just promote it to performance environment. Meanwhile, the artifact which is already passed these auto tests, these artifacts can be injected into another environment. You can see on the lower screen, for example, there is a bank release 1 microservice, and someone is working on a card, and he wants to check the feature with card and order feature 5, but at the same time this order feature 5 must be passed all those auto tests we defined here on the top. So then he's able to create this environment from the EDP. At the same time, he can provide an option that each time artifacts appeared from the card dev, they will be automatically deployed to the card seat environment, and then auto tests running. Here you can see that we have also another one manual gate, which means that if in the first case auto test passed, then we're just promoting artifacts to the higher environment. In the lower case, if auto test passed, then QA is still responsible to promoting these artifacts. If, for example, auto test passed, but something is not correctly, or QA finds some bug in auto tests, then he just abort, and those artifacts will not be promoted to the higher environment. So today I will discuss and show you actually about this. So to ensure that we can configure these pipelines, there exists, let's say, CD pipeline operator, and here are the entities and their relations in the pipeline operator, which are responsible for configuring exactly what you want from the CD pipeline. I will show you later, let's say, properties of these entities. So demo scenario for today. For today, we are going to quickly create a new Java application from the existing library. This is the first scenario. And then just simple CD pipeline with 3 environments. Then I will demonstrate you on how to integrate an existing code. For example, this code will be hosted on GitHub environment. And the last one, I will just add React application and deploy 2 microservices. The first one, let's say, from my previous pipeline, because, for example, I know that this artifact passed SIT environment, it passed QA environment, then I'm ready to work with him in my own environment. So this is how it looks like in general, and we'll go through all the steps. So first demo scenario. So CI pipeline will look like this, and CD pipeline is going to be configured in this way. I'm going first of all to use UI approach just to show you how EDP looks like. I mean, by providing something using UI approach. So I believe that this session is still alive. Okay, just 1 second. I need to connect to VPN first. I believe, okay, I believe connection is still. Okay, this is how it works with a single sign-on. You just see that I have just authorized against identity provider, which is used in EPAM. So here is my user here. I have an admin privileges for this EPAM Delivery Platform, so I can manage most all of this stuff. If you're a developer, you can view and did some small configurations. So let's start first of all with the creating application. Then while it will be provisioned, I will just briefly go through all these components. So let's first go with the create strategy. As I said before, we can use create if we want to, for example, to create some microservices with pre-existing library. We can use clone strategy. This is how we're going to go with my second demo. And we can use also import. If you remember, we can work with GitHub and GitLab. So I can just onboard them using this import strategy. Let's go with the create one. Then let's create application. Let it be manual, let it be master. Let's go with Java. Let's use Maven tool. Let's go to this section. So in advanced section, you can define CI provisioner, which defines actually the logic on what are the building blocks here. on this slide. So I'm going to use the default one and not going to change anything. So regarding Jira integration, I will show you later, we'll have time. You are able to populate your values from this pipeline to Jira and to see these values inside the Jira. So we are going to use Helm chart for the deployment. So I need, for example, root for this application. Let's call it root and the path for this application. So while application is provisioning, let's briefly go to the sections. So service sections, I'm not going to stop here for a long time because in 2 weeks it will be deprecated and removed. So here we stored some services which you need for your microservice architecture, but now it is managed by the Helm charts out of the box. So EDP, we don't need EDP here. Okay. Okay. Something is happened. Okay, here it is. So automation tests, I've also added them before. This is the quality gateway you can run against your environment. I used just a simple example of my auto tests, which actually does nothing but just saying hello. Definitely there might be your logic implemented in automation tests. So I used Gradle and yeah, here's how it looks like. There is a library section. It's also approximately the same as an application, but instead applications, as I said before, since we're working with microservice architecture, application expects that you will have deployment templates and Docker files. In case of libraries, this is not true because it can be just simple Java library. This can be JavaScript, this can be .NET, this can be Terraform as well, this can be Python. So the result of these, the artifacts of this library section is just something in Maven repository, in NPM repository, or whatever, depending on the tool you've just selected before. So I'm not going to stop here for a long time, just to cover the purpose of my today's demo. So you can see that this application was created. You can go, as I said before, we use Gerrit, so you can go to VCS in our case, and you can open Jenkins. So we're using Gerrit heavily. So here how the code looks like. So this is some basic Java application with something like hello, blah, blah, blah. And as you can see, a new folder was created for this manual application, which provisioned 2 pipelines, build pipeline and code review pipeline. So now build pipeline is triggered and actually is running and doing all the stuff with Maven application. What is actually he's doing is defined in the CI pipeline provisioner, and actually here are these steps. So we have the steps, you just define them, combine them, and you will have a pipeline as the result of the execution of it. And we have a code review pipeline. It can have the same steps, but can be slightly modified if you have some requirements. I don't know, if you want to run not only Docker file int, or for example, we want to run OPA agent, or I don't know, JaCoV and other linters which are not implemented in EDP, and you just adding them using our recommendations and help. So after this application is created, let's go to admin console, return back. We have a continuous deployment tab, which is responsible for provisioning all those pipelines. As you remember from our scenario, we're going to deploy this CD pipeline. So I select these applications because we have manual master applications. I want to promote it through the stages, and now I'm defining the stages. What is stages here? It's actually namespaces in Kubernetes. So here I can define. Here I can. Where's my? Just a second. I don't see my mouse point. Okay. Okay, something weird is happening with my I'm not able to see. Let me try to, let's go to continuous delivery. No, just 1 second. I will try to debug my mouse. Okay, let's go with the touchpad. So here we can create manual. Here we can select applications which we want to be deployed to this specific stage. Let's call it, I don't know, SIT, integration environment, integration. We agreed that this quality gate is going to be manual. So someone must prove this pipeline. And then we can select different triggers type. It can be auto triggering and manual. So in our case, let's go with the manual as an initial scenario. Then we can create another environment. This can be, I don't know, QA, for example. This is the high environment. We're ensuring that artifacts from the SAT goes to QA after it passed successfully. I don't know, let's test 10. Then let's define a step which is going to be used to promote this artifact to the higher environment. And again, services will be deprecated, they will not create it here. So the pipeline actually is provisioned. We can go here and to check how the things are looks like. So you have SAT environment, you have QA environment, and you have quality gates which were defined beforehand. So as the result of this manipulation, a new pipeline, new folder is going to be created, and these are two folders you can see here. So if I want to start, I don't know, deployment for the QA stuff and starting deploying something, and then let's return back, and now I want to deploy SAT environment, then in case of QA, I'm waiting artifacts I want to deploy to this specific environment, and as you can see here, I don't have any images. This is because artifact was not promoted to the next environment. So in our case, artifact is not available here. So let's abort this pipeline, then let's return back, let's go to SAT environment, and then you can see that we have an artifact candidate for the deployment. Let's go with the deployment. Meanwhile, I will show you from where we have this artifact. So CI pipeline is finished, and we have this artifact here. It was produced and successfully pushed to the registry and properly tagged. So that's why we're able to see our artifact on the environment. As soon as the deployment is finished here, then we can make a decision. Do we want to promote this artifact to the higher environment again? So technically, what we're actually doing, we're just using Helm for installation. So if your project is not going to use Helm, or you have some specific tools for the deployment, then again, EDP will not be an option. You will have to modify it somehow. So we can go to these applications. Actually, it does nothing. It only shows like white label error in our case. And if everything is okay, then I can proceed with the promoting these artifacts. As you can see, the magic here is happening is that we patched some component in Kubernetes, and this is exactly the code-based image stream I shared before. I will return back to this topic as soon as we will going to deploy everything from the code. So as soon SAT was successfully deployed, we promote the artifact to the higher environment. Let's try to do the deployment on the QA side. So let's wait a little just to grab all the informations which are required for the deployment. And then here it is. Here this artifact is available on this environment as well. So let's go with the deployment and return back to this panel. So again, this is how it looks like from the perspective of manual deployment. Now let's return back to our slides and do the same stuff with the declarative approach. So before switching to the terminal, I will just briefly describe on what you see on the screen. Actually, this is some of the objects which describe the state of our CI/CD pipelines for this specific application I've just created manually. So we have a main entity which is code base and the specification sections which defines which tool to use, what is the application strategy, is it going to be cloned or created, what is the language, what is the provisioner for this stuff. Then we have a code-based branch. Since we're using for now master branch, then this is the only entity here. If we want to create release branch or any other branch, this is also can be created using this approach. The thing is that why we're doing this with the, for example, just not to git checkout, git branch, etc., because it's also possible, but when you're creating this stuff using EDP, you're ensuring that your branch properly propagated not only to Git, but to Jenkins, to Sonar, to other tools which are relying on this branching strategy. So CD pipeline, this is our pipeline which we created before. Here it is. And the stages or environments and how the artifacts are moving from environment to environment is defined on this, on the lower slide of this slide. So we have dev environment, SAT environment, QA environment. We have orders of this environment, names, and different quality gates, which can be defined here as well. So let's go to this code. I've just prepared some 3 examples. The first one, okay, is Maven create. This is what I've just shared before. So believe me, these are the same YAMLs. I've just copy paste on the slide. So let's apply them. Let's apply. Here is the create one. So I'm just using Kubernetes native tool kubectl, and it creates the entities which are responsible to ensure that our pipelines will look like what we've just defined. If we go, for example, to let me go back to our application, to our EPAM Delivery Platform. So you can see that this application was created here. It's still provisioning. Yes, it's true. So if we go to continuous delivery, we can see this pipeline, which we just defined in our YAML format, and we can see the quality gates, which we defined in YAML format as well. We see that there is no deployments yet to these environments. By the way, if we go to this manual stuff, you can see that you have some artifacts already deployed to this environment. This is a small, like let's say, board which we are going to extend with populating more metrics from Grafana, from Kibana, with the proper links to the environments. So now let's a little bit speed up. As you can see, we've created just the same manual approach, the same application, but with just kubectl apply command. And we have, by the way, we can go to Jenkins as well, and we can see that this application, this is Maven, Java Maven create, was created, and again, build pipeline was started, and again, we have the same CD pipeline, number of CD pipelines created. So now let's go to our next scenario. While it is provisioning, later I will return back to. So the second one, just imagine we have an existing code somewhere. It can be a private repository, a public one, and we want to onboard it on EDP. In our case, this is going to be a Spring Boot Pet Clinic application. Then we define some steps. As you can see, I've just put here something that we changed from the previous example. We defined a new quality gate. We're going to use automation tests, and probably the same key environment is looks the same as we have on the previous step. So let's go. What is Pet Clinic actually? How it looks like? This is my repository. I've just forked this Pet Clinic just before the demo, probably 1 week before, just to show you what is difference from the upstream and what is the EDP expected. So since we're talking about the microservices again, okay, it seems my pointer is hide again. Okay, so you can see that I've added just Docker file in the root folder of this repository. It contains some slim image for OpenJDK 11, and also I've added some exclusions to style check, because this folder is created by the EDP, and then it is populated with deployment templates. So I have to do this, otherwise my CI pipeline will fail, saying that something is wrong with your deployment templates folder. So that's it, actually. Now let's return back to this example, and let's try to deploy it. So here is this application is here. It is cloned. I already prepared it before. Again, code base. I provide a repository from where the code should be picked up. I've defined the stages and quality gates which I want to use for the project, and then just go here and saying that I want to apply changes from this folder. As you can see, those objects was created successfully in Kubernetes. Now let's go to our admin console and to check all the stuff. So as you can see, pet clinic clone is provisioning. You can see that continuous delivery pipeline was created. It's called pet clinic. We added automation tests, and these automation tests actually is here they are, and they are used as the quality gates for this specific environment. So this is how it looks like if we are going to add something quickly with strategy of clone something. So you can define your libraries, you can define your repositories, your baselines, and then just using the same strategy on board your application quick. So let's return back to our slides, and let's check the third scenario I want to share. Probably it's better to see this scenario from this slide. So we want to get artifacts from this, let's say we know that this is our pet clinic, and we want this pet clinic to get from this environment and deploy it together with some React application on our own environment. For example, I'm a AQA which is developing automation tests for current features. So I need some at least stable code with some React applications, and I want to test something against those two microservices. So this is how it looks like from the perspective of the declarative definition. We just need to define a code base because we're introducing a new React application. It has the same structure, but just the difference between the tools and lengths and frameworks which are used to populate and onboard this application. As you can see, what is changed in CD pipeline, since I'm going to consume two different microservices. The first one is the React Create, and the second one is a pet clinic clone. I should mention it here. And also I need to define those input Docker streams for this exact pipeline. In our case, it is like React Create Master, which will be produced by this repository. And this one, pet clinic QA, pet clinic clone verified, is artifacts which came from upstream for some other job. And then I also going to use automation tests on some of the stages, like here you can see feature. So let's go to our console. I have also prepared this for you, just what I've shared on the slide, and I'm going to run the same Java React. So this application is going to be provisioned. Meanwhile, let's return back and to check what we have at the result. So we have Jenkins, which is onboarding all the tools we've just defined before. We have CICD pipelines, which is also used to deploy and define the strategy on how to promote artifacts from environment to environment. So let's check the pet clinic clone. It will take like longer time than our simple example application, but let's wait a little. What you can see here, we can go to our Sonar. We can use to with OpenID, and you can see, since I'm administrator, I can manage this instance. I can see that all the projects which we created before successfully landed on this Sonar. So we can check, for example, some statistics from the pet clinic clone upstream. So we have code coverage, you can define quality gates, you can fail if the coverage changed. So this is also possible, but out of scope of today's demo. So let's return back to Jenkins. As soon as the artifacts will be built, we will be able to start deploying something. For example, let's go to this pet CICD clinic. Let's check. Okay, it's still building image. So what is actually happening? Let me try to show you on a, if it will be possible. Yeah, so you can see I've mentioned before a custom resource definition. Some of them are related to third-party services. In our case, we're interested in this EDP stuff. So we can see that we have our code bases created before. We can see that we have here they are. We can see that we have, I don't know, some stages we defined. We can see that we have, for example, Jenkins folders, which was created, Jenkins jobs, which are responsible for creating these pipelines, and other objects which are used to define the state of your pipelines and state of not only pipelines, but CI/CD itself. So let's probably return back to this. So we have successfully built pet clinic. Now let's go quickly and try to deploy in this pet clinic to SAT environment. This is important because, as you remember, our last onboarding procedure for this scenario, just one second, okay, this one, you can see that we are depending on artifact which is going to be produced by this stage. So while this artifact is not pushed to this stage, we're not able to deploy this environment. That's why I want just to trigger all this stuff and promote this artifacts forward and to deploy finally 2 microservices on a single environment. Let's return back to our feature CICD pipeline. So if I will try to deploy our feature environment, just one second, how it looks like. So the feature environment expecting artifacts from our React application and from our QA pipeline. And then I will have automation tests, which promotes all the stuff to RQA. Let's go here. Let's try to build this feature and deploy 2 microservices on this feature environment. We can start AQA, but actually it will show that no artifacts to deploy. So do not do this. Okay, again, pointer is disappeared. Okay, it's here. So let's go to feature. As you can see, no image to be deployed, and we can at least start deploying our React application because the artifact is already produced. So let's go with the deployment of the single microservices. Meanwhile, we are going to promote all the stuff from Pet Clinic CICD Pipeline. As you can see, seed environment was deployed, and let's go to check what is our auto tests and how they are actually doing. So as you can see, our application was successfully deployed. Here it is. By the way, we can go and to check this application. Road. So here is our pet clinic. This is how it looks like. Now let's return back to our CICD pipeline, and you can see that we started a simple automation test. They are just doing just saying hello. So I believe they will return like everything, hello world. So no issues, and we are then saying that everything is good, and we are able to promote artifacts. Since there are no more quality gates, only automation tests, we are okay to promote this artifact to the higher environment. Then returning back here, then let's build this with the parameters and deploy this promoted artifact on this environment. So while it is promoting, a few words a little bit about the capabilities. I've mentioned that we have like Grafana. So my session is out of date. Let me relog in. So this is how my environment looks like, but let's check our, I don't know, pet clinic seat environment. So we can see that let's 1 hour is too long. Let's check for the last 5 minutes. This is how our container pet clinic lives. So it uses this memory, it uses this CPU. You can drill down to different options using this Grafana, but let's postpone it. This is the first capability you have. And the second one is let's go with OAuth, is the ability to grab the logs for your specific environment. So here I use you can see the logs for our reconciliations, what our operators just doing. But let's, for example, select here, let's select here demo pet clinic seat and show logs. So you can see here the logs of our container, how it looks like. I believe we can extend it to the last 15 minutes. So let's wait a little to all the logs appeared in this, but actually this is how it looks like from the platform perspective. So if we are talking about the Jira integration, I've just opened some pre-existing story, and you can see that, for example, we have like 2 artifacts related to this story. This information was injected here, the versions of this artifact. We're also populating, for our release purposes, fixed version and components here as well to have more, to build more beautiful and meaningful meaning reports for us. So let's return back quickly. Let's deploy our image. So as soon as this image will be deployed, we can return back to our last example. This is the feature, and then we can deploy this environment with all the stuff. This is how everything is look like. I believe let's return back to the end of my presentation. Lessons learned. So idempotency is a very important in the operator's logic. So you need to ensure that your operator works properly, and you ensure that you can put your system in the exact state. So definitely spend more time to ensure that you have a loosely coupled architecture. So this is a separate topic of discussions, but I believe it's also worth to mention we have issues with this approach. So do not try to address everything in operator. So if you have some applications, probably it's better first to check whether you can manage it with simple configuration maps, and that's it. Just not to create and reinvent operator approach. Automation test is the must itself. So from the infrastructure perspective, try to run all your workload in a single AZ, because if your cluster runs in multiple AZ, you can, and you have some traffic, then you will pay for this traffic. And use custom resource validation wherever it's possible, just to ensure that, let's say, specifications for your custom resource is verified on Kubernetes site as well. The further step, we don't have actually updates for all of the EDP components you saw here. So if you ask me a question, what if I go to this custom resource and change field from, I don't know, from automation tests to manual improvements? So for some simple cases, now it works, but we still have a lot of different scenarios which we didn't address yet. So, and this is our next steps. We also still store some persistency in EDP database. And here we want to get rid of it and move everything to the custom resources. So we also want to introduce releases and conventional commits, and as a result, automation generation of change logs, which is the best practice used today. TerraGrant is going to be wrapped our Terraform. And I mentioned before, we want also provide users capability not to run with Jenkins, but try to define their workflows using either Argo workflows or Tekton as well. So secret management is another one task we're just currently working on, and definitely introducing SAST and DAST as well. So this is all from my side. Thank you for your attention. Your questions are welcome.
Yeah, thank you very much, Sergey. Thank you very much for such a nice presentation. So, guys, if you have any questions, we're still waiting them in YouTube chat. Before we proceed with questions, I want to ask you to click subscribe button, click like button, and bell button, so you would receive notifications about our future webinars. And also, this would rise our channel in YouTube for YouTube algorithms, so we'll be higher there. Okay, so we don't have a lot of questions here. We have one small question. So if we would be able to share the YAML configuration scripts which you showed on the presentation.
Yeah, actually, it's possible. Moreover, we have this repository in our EDP. The only thing, we just need to share it on the GitHub. So no problem. If you need it like in 1 minute, let's say till the end of the day, then I can personally share these configurations.
Yeah, I want to say that we will send the email with the feedback link, and guys, please fill this feedback. It's really important for us to have it. So, and in this link, we would ask Sergey to prepare a link for GitHub, and while we will prepare it, we will send it according to the email. So, not if you don't want to miss it. So, in description, there is a link to Community Z portal with this event there. Register there if you haven't, and you would receive this email with all this stuff. Okay, we have another one question. It was asked in the beginning of the presentation. I would try to just read it because I'm not sure that I fully get it. Did you have opportunity to see CICD environment and you are sure it was not CICD? Live example about bad implementation that no one knew it was wrong.
Probably it's better to rephrase the question. So have I seen what CI/CD environment?
Yeah, have
which
you
is
seen
not
some CI/CD environment which is actually not CI/CD, and maybe people think it's CI/CD, but it's really not. That's how I get this question.
Yeah, definitely. I mean, if I let's say in this way, have I ever seen environments which are not configured properly from the CI/CD perspective? I mean, it doesn't cover all the cases, or it doesn't have friendly or ability to introduce some changes quickly, and you have to, I don't know, to reinvent something. Then these are the kind of examples. That's why one of our action item is just to try to onboard Tekton or other open source tools, because they already have some shared steps which are provided by community. So you can use EDP and at the same time use Tekton and use pipelines which are provided by community as well.
Okay, great. Thanks for the question. We have another one in the chat. Is there any security concepts and implementation behind the platform?
So security is like a really huge topic. So we can talk about, for example, single sign-on. If we are talking about authentication authorization, then we're using Keycloak heavily, and we integrate it with all our tools to ensure that actually we are not storing any passwords on EDP side, and we are relying on some identity provider. It can be, I don't know, Azure AD, it can be Google, Facebook, or whatever, which knows how to work over the SAML or IDC as well. This is the first question. This is the first step. And the second one, we started, actually we did it before, but now we started to work closely on the results of our dust reports to address all those issues. For example, if we are talking about the releases, we are all time scanning our Docker images for some vulnerabilities, and if we will have one, and if it is critical or at least high, then we deliver a hotfix to our previous version. But the rule of thumb for EDP, each time we deliver a new release quarterly, we upgrade all the components to the latest stable, which covered and addressed all known vulnerabilities existing till this time.
Okay, great. Thank you very much for this answer. I don't see any more questions in the chat, so I think that we may wrap up with this talk. So, Sergey, thank you very much again for this talk. It was really nice. We have a lot of thank yous and saying that it was cool, and thanks for the presentation. So thank you very much for being with
Thank you.
us. So I prepared this talk. Guys, I want to say again thank you for being with us and looking for this webinar. I want to remind you that we'll have some letter after that if you're registered on CommunityZ page with the feedback link and some links from this presentation. So please spend a couple minutes to fill this feedback so we will know your opinion about this webinar and we will try to make these better. So thank you very much all and see you in the future in our next webinars. Thank you very much. Thank you. Bye.
All. See you. Bye.